Okay, in this video I will be demonstrating the speed advantage that Didgets provides over Postgres for the Chicago crime data. Other videos on this channel show how we can analyze that crime data or do queries against other data sets, but in this one we'll just be doing a set of queries against this Chicago crime data. Now, the City of Chicago on their Open Data portal publishes all the crimes from the start of 2001 until the current time. There's an export function here where you can just go download a CSV file. It's a couple gigabytes, but it'll have every crime that they've put in their database. So I did that. I just downloaded that in and imported it in. The one from today has almost 7 million rows in it. I have another one that I imported about a year ago, so that you can see there's about almost 400,000 crimes in the past year that have been reported in the city. But I took that data set and imported it both in Didgets and in Postgres. So under Postgres, you see I've got the table. Here's the table with 6.5 million rows. The indexes that I've created against that table. Now bear in mind, indexes in Postgres can significantly improve the query speed of very large tables. However, there's a performance penalty on updates to those tables. Every time you insert a new row, update an existing row, or delete a row, you have to go in and update, or the software underneath has to go in and update the index as well. So the more indexes you have on a particular table, every time you do an update, the slower that can be, because it has to go update all those indexes. Now in our case, we came in and I created a bunch of queries against those. One query where we're significantly faster is this one, where I'm selecting everything from the crimes table where the description starts with the letter TO. So for crimes like criminal damage or criminal trespass, they would put, to the City of Chicago property, or to vehicle, or to other things. And so I wanted to go find all the rows where the description started with the letter TO. You see there's 905,000 rows out of our table where that happens. If I do it again, it'll create another data set, same thing. I have my performance monitor on so I can go see how long each one takes. The last one took about 91 milliseconds. This one took 93 milliseconds. So very short time we can go get that information. If I copy the SQL in there and go back to Postgres and I type that in, so this is going to find all the description where it starts with TO. Run that thing. I do an explain analyze, so it's not actually getting the data, it's just going to run the operation and tell us how long that took. So in this case it took over 7.5 seconds. To do the same thing we took 93 milliseconds under Didgets to do. Run it again just to verify that. 5, 6 seconds, 7, so about the same, over 7.5 seconds to do what we did in Didgets. And the reason why is because the description field does not have an index on it. So it had to do a sequential scan and pull all the data in. Let's go look at a query where we do have indexes. So for example, here's battery. So we want to find all the rows where the primary type is battery and the block contains an S. So we're looking for the battery crimes on the south side of Chicago. So any street or avenue that has an S in it, we're going to go grab those. Again, we'll do a query. In this case, there's 550,000 rows. Again, we'll do it a couple times just so we can measure the performance and average them, so we come over where we keep track of that. So it took 830 milliseconds here and 841, but yeah, still under a second to do that particular query. Let's go back to the database. We'll copy the SQL to the clipboard. Come back to Postgres, put it in, and run that. See how long this takes. It's 2 seconds, 3 seconds. So a little over 3 seconds to do what we could do under 3. So 3 times faster in Didgets versus in Postgres. Let's run it one more time. Make sure it's consistently over 3 seconds. It is. And you'll see it used the indexes we created. So we had an index on the primary type. We had an index on the block, so it was able to do this as fast as I can figure out how to do under Postgres. And still, Didgets was more than 3 times faster. Let's go back to Didgets and find another. Here's summer crimes on a street or an alley in wards 10 through 15. So this is a fairly complicated query. We run it under Didgets. Run that a couple of times. Looks like it's taken a second or so. Over to the markers and find out. Yeah, in fact, it took little over a second and a half to execute that. So in this case, almost 2 seconds. But still under 2 seconds to execute that query. We'll come and copy the SQL to the clipboard. Come back to Postgres. Run that same query under Postgres on that same data. So we're looking for dates that start with June, July, or August. The location is a street or an alley, and the ward is greater than or equal to 10 and less than or equal to 15. So fairly complicated query. In this case, on Postgres, it's taking more than 8 seconds, 9, 10. Took 11.5 seconds. And again, we're using the GIN indexes. We're using various indexes. So we didn't do a table scan on this. It used whatever indexes we created here. We'll try it one more time. Last time was 11 seconds. Maybe this time it'll be a little quicker. In any case, it's significantly slower than the 2 seconds it took under Didgets. In this case, just under 11 seconds. But still, we're at least 5 times faster under Didgets for this. And I created a bunch of queries. There's more than a dozen different queries of various things where this variable primary type starts with letter B in 2012. Let's run that a couple of times. See, it returned 124,000 rows, and each time took, this is the fastest one, 773 milliseconds. So it's way under a second. The base, go back and let's copy that to the clipboard. Back to Postgres. Put it in there and hit it. It's 1 second, 2, 3, 4, almost 5 seconds to do what we could do in under a second. And this is very typical of this particular data set, which is almost 6.5 million rows of crime data. And this is, I've yet to find too many queries where we're not at least 2 to 3 times faster, and sometimes we're 30, 40 times faster. So Didgets, in Didgets, we do not need a separate indexing step. There's only one copy of each piece of information. So updates, deletes, inserts are not slowed down because we have to go update indexes. Nothing to maintain, nothing to clean out. We just query the data and do it fast. Thank you very much.